Nitrogen, right? So we know that there's liquid nitrogen. There's still liquid hydrogen, but it's at very, very, very low temperatures, and so there's going to be larger van der Waals forces here. Yeah?
Did you say closer molecules have higher van der Waals forces?
That's right. So as you bring two molecules close to one another, the van der Waals forces are going to increase with r to the 6, right?
But wouldn't the nitrogen molecule be a lot bigger than the hydrogen molecule?
Yeah, so think about, so that's a different issue. It's not based on...
Because you already done the relationship was like 1 over r to the 6th.
Yeah.
So that r...
So it's not based on this. So this is so you have a distance between these, right? And so as you move the hydrogens closer and further away from one another, the force between them goes with 1 over d to the 6th, or 1 over r to the 6th. However, if you have a nitrogen here, we know that there's a lot more electrons in nitrogen. They're bigger. They're going to have larger van der Waals forces between them. Nitrogen to nitrogen versus hydrogen to hydrogen. So don't get confused with when you take two of the same molecules and move them closer or further apart, how the van der Waals forces change versus the van der Waals forces when you compare hydrogen versus nitrogen. So if you have, say, two nitrogens, let's see, and they're the same distance apart as two hydrogens. So the distance is the same for both of these. Which one's going to have the greater force between them, hydrogen or nitrogen? Nitrogen. So really when we compare van der Waals forces, we're talking about things that are the same distance apart versus if we take the same molecule and move it different distances apart. So don't get those two confused. Any other questions? Okay, well I'll be on email tomorrow. I'm not going to be in my office until tomorrow afternoon, so if you have questions, just email me, make an appointment. I'll be here until 6 o'clock or so I'm happy to answer any questions by email or face-to-face, but I won't be in my office in the morning. And then, since your exam is early, at a reasonable time on Tuesday morning, I probably won't be answering any questions on Tuesday morning right before the exam.
Right.
Anything else?
In the beginning of class, one more question. How you said we can interchange between delta G and the Nernst equation?
That's right.
Can you show an example of that real quickly?
Sure.
There's a good triangle notes too.
It's a delta G equals to negative NF itself. It's a bridge between two.
So the Nernst equation is E equals E0 minus RT NF ln Q. Delta G is delta G0 plus RT ln Q. So if you substitute in delta G0 here is negative NFE0, and then you substitute in delta G is negative NFE, and you divide the whole thing by negative NF, you go between these two equations. So just take these four equations home, and this is how you go from delta G to Nernst. Yeah?
Can you focus at all on the units? You say what's the unit, the second order rate?
Oh yeah. So these units will work out. Remember, you still have units here, so you have kilojoules per mole, units of N, units of F, units of E. So the units are fine here. For the units of second order rate constant,
There was a specific question on that last exam.
yep, K is, rate equals K times concentration of A squared. So this is second order, let's say. So what are the units of rate?
M per second. Oh,
Mole per liter per
per
second, or this is molar per second, right? How does the concentration change as a function of time? That's what a rate is. What are the units of concentration?
M squared.
Mole, and it's going to be mole squared in this case. And so you need to figure out how to get this, the same units of this, so we're going to have moles here, right? So we need to get rid of this exponent, so we have moles, we've got seconds, and what else do we have?
All the copies one.
Liters.
Oh, this is moles per liter. Yeah, sorry. Moles per liter. Is that right? Hold on,
I think
I'm confusing myself here. One sec.
So just make M.
Let's just make it M, right? So this is M squared. So we're going to have M over seconds, right? So this is, yeah. And this matters whether we have first order, rate equals K times, let's say C, right? So the rate is molar per second. And if we have molar here, we just have per second for K. And so this is how we work out the units. So for a 0th order, first order, second order, all the K's are going to have different units. And that was a homework problem, so you can look at the solutions there. But just make sure the units work out. Yeah.
Are we gonna be allowed to have a quick sheet?
Oh yeah, you bring your sheet, just one. That's all you'll need. Ruler, calculator, pencil, all that stuff. So the final runs just like a regular exam. Of course, you have an hour and 50 minutes, but I'll tell you the final's just about as long as a regular exam. It's not some mega final. It just covers a little bit broader topics. So it's going to have 10, 12 questions, just like a regular exam. Yeah.
Can we bring a periodic table too?
Sure. No problem. Okay, see you on Tuesday morning.
So you mean that I can choose